Control, sonar, I have a new contact, bearing 320.
The world held its breath. From 1940's breath.
The Alpha class uses a much smaller reactor space than the Permit.
Yes, but look at the depth rating on the Thresher design.
The race for underwater supremacy defined the Cold War. Here we see the competing designs, the massive Soviet project.
The Cold War demanded unprecedented feats of engineering.
Lower the section now, easy on the descent.
Coming down, watch your heads below.
This section here, the ballast control needs refinement before the review on Friday.
I agree. The current specs won't hold up under pressure. Let me adjust the schematics.
The stress calculations at this section are marginal. We need to reinforce the plating.
What's the revised estimate for the forward ballast tank?
The readings on the mainframe match the slide rule estimate.
Good. The hull can withstand the pressure at that depth.
We need to ensure the depth resistance holds. The calculations for the hull require absolute precision.
Agreed.
The pressurized water reactor here is vastly more complex than the diesel-electric setup.
But look at the patrol endurance. We couldn't achieve this with batteries alone.
The reactor shielding is finalized here, Captain. It meets all specifications.
Very good, Mr. Volk. This design is approved. Proceed with construction. The structural integrity here is critical for the dive depth.
Yes, but the weight tolerance for the reactor shielding is already maxed out.
If we adjust the ballast intake here, we reduce the trim angle during the dive.
That solves the stability issue we projected.
Agreed. Proceed with the modification. We need to align the plate right here before the next shift starts.
All right, I'll signal the crane operator now.
We're holding steady at 4.5 inches.
4.5, copy that.
Plate 7.
The early stages of submarine construction relied on sheer force. Massive steel slabs were maneuvered into place by powerful overhead cranes.
Hull integrity is nominal. The HY-80 is performing as expected.
All right, let's keep moving.
All right, bring her down steady. Watch the clearance. All right, easy on the clamps. We're clear on this side.
The construction of these submarines began with the precise movement of massive steel plates through the factory.
All right, lower the plate. Easy now. Coming down. Watch your hands below. A little more pressure on roller 3. We're almost there. Hold it right there. We need another inch to the left. Welders, stand by.
In the massive Cold War-era shipyards, these colossal sections were joined by intense welding, forming the backbone of the fleet. The Goliath crane begins the critical descent, lowering the massive pressure hull into the dry dock. Precision is everything at this stage.
Bring it down slowly. Watch the starboard side. Steady, steady. Hold it right there. Reading is 34 feet, 7 inches.
Confirmed on the mark.
All right, I have it. Move to the next plate.
The internal bulkhead was a critical structural component, lowered carefully into the cylindrical hull. This was a precise operation.
Bring her up slowly. Watch the gauges. Pressure stabilizing at 5,000 psi. It's holding.
Acknowledge, Command. The hull section is approved. Commence transfer to Dry Dock 2.
We are approaching the alignment ring. All teams confirm green status.
Team Charlie reports green.
Hold steady. We have contact.
Move that ducting to the starboard side.
Careful with the welder. Watch your step.
Deep within the hull, the control room takes shape. Workers meticulously assemble the foundation, a complex web of steel and heavy cabling.
If we route the primary conduit through Section 4, we bypass the auxiliary controls entirely.
That clears the path for the secondary system.
The F room, the engine room, the very heart of the vessel, demanded unprecedented precision. Here,
A little more to the left. Okay, hold it steady. Let's secure it.
The fire suppression systems were critical. Here we see the intricate network being carefully welded into place.
A little to the left, easy now. Got it. All right, start turning the wheel, push hard. As you can see, the pressure on the central gauge is stable.
Okay, I've logged the reading.
All right, men, pressure looks good across the board. Secure the hatches. Easy now, bring it down slow. Watch the starboard side clearance.
We're clear on this end.
All right, hold it right there.
A little more to the starboard. Steady. It's in position, sir. Start the impact wrenches.
We have to check the alignment on Gamma 7. The tolerances are tight right here on the schematic. Ease it back 10 thousandths. Hold it right there. We are within tolerance.
Hover bar casting. The massive bronze propeller casting was a critical step in Cold War submarine construction. Here we see the molten metal
All right, bring her down slow. Easy now.
A little to the left, steady.
We're in the keyway. Hold it there.
The installation of the vibration dampening system was a critical step in reducing the acoustic signature of the submarine.
Gauge pressure on auxiliary pump is still high.
I'm adjusting the flow regulator now, sir.
All right, lock it down.
Maintain pressure at the red line.
Check the forward bulkhead. I think I see a leak.
Pressure holding steady.
Schematic calls for the blue wire on terminal 47.
47, checking continuity now. Looks good.
All right, bring it down 5 more inches.
5 inches, Captain.
And hold it right there. All right, easy now. Watch the housing. Steady, hold it right there. The schematics show the power coupling here.
All right, connect the main leads. Let's see if she lights up.
Dialing up the frequency. Check the telemetry stabilization.
It's holding steady at the critical threshold.
Switching bank 4 to auxiliary power.
confirming voltage stabilization on the scope. We are green across the board.
Easy now, keep it steady. Clear on the left side. Rolling it in. Stand clear of the breach.
Ping localization bearing 090, sir.
Maneuver to course 180, all ahead flank.
I said secure that valve immediately. We need absolute precision here, mister.
We have full illumination emergency lighting grid. Voltables. Main ballast control, open the valves.
Acknowledged. Flipping the lever now, sir. Pressure stabilizing, reading green.
Maintain depth at 200 feet.
Emergency ballast blow initiated.
We have flooding in the auxiliary forward compartment, Helm.
Engineering reports system stable.
Very good. Systems green lit. Prepare the dive.
All right, team, secure that lower plate now. Watch the alignment on section 4.
Copy that. Almost in position.
Securing the exterior pressure sensors was a critical step, requiring precision and the heavy-duty pneumatic tools of the era. The installation of the rudder and dive planes required immense precision, utilizing the heavy machinery available during the Cold War era.
The schematic calls for the main ballast tank vent here.
But the weld looks incomplete. We need to make a note.
The massive pressure hull, built to withstand the ocean's depths, nears completion.
Deep within the shipyard, the heart of the Cold War machine takes shape.
Check the tolerances on frame 72. Make sure it aligns with the schematic.
Thermal expansion accounted for, sir.
The welding on the ballast tanks looks secure.
Blueprints match the current structure, sir.
Excellent. We have exterior approval.
Control to Group A, confirm cradle release sequence.
Sequence initiated. Control. We are green for launch.
Con, new contact bearing 045.
Confirm the classification, mister.
All ahead slow on the tug. Check the stern lines.
Hey, checking stern lines now. Pressure holding steady at 2,000 psi.
Throw the lever, Commander.
Ignition. We have a successful light off.
We have positive lift on the stern.
Copy that. Forward ballast clear.
Scram the reactor. Pull the main breakers.
We're secure on the lower deck. Door closing.
Lower it steady. Watch the alignment. Pressure's holding steady at 5,000, sir.
Good. She'll hold.
We have confirmation. The dive was a complete success.
Hurrah!
Well done, Captain. All right, men, move it along. Watch your step on the gangway.
Yes, sir. Moving up.
And so the massive hull begins its descent. This critical first trial marked a new era in underwater capability during the Cold War.